Okay, so it's time to start the second kind of major part of this project, which is figuring out the drive for the gantry, which is essentially the y-axis for this machine. So I've got some motors, some belts, pulleys have all arrived. So basically what I'm going to try and do now is figure out the best way to mount the motor and couple the belts to the drive belts to the gantry on either side. So at the moment, first kind of idea is to have the motor sitting back here. There'd be one of the pulleys on the end, and then a belt come off here, run through here underneath the gantry, sort of attach onto somewhere underneath the gantry here at the bottom, and then the belt will continue on out to here, where there'll be like an idler at the end, which I'll probably use one of these pulleys for. So then as the motor spins, belt pulls along and it'll pull the gantry along with it. So you see there actually even there's a little, it just caught as I was pulling on one side in that racking angle. So the same thing will be done on the far side, and the two stepper motors will be driven in sync, which hopefully will mean that that won't happen. They'll both move like evenly. That's the theory anyway, but we'll see how that works in practice. So off the bat, I do have a couple of concerns. I knew what size motor I was buying when I purchased this set of 3 of these. They weren't super expensive, but now that I'm holding it in my hand and comparing it to the size of the machine, it feels a little puny. So yeah, we may have to revisit the motors at some point, especially maybe it'll work if this is just driving a laser or a pen plotter, but I'm not really certain I'll be able to have much grunt in terms of cutting anything. And well, to be fair, I mean, I don't know if this machine will ever be able to cut very much aside from maybe some little bits of plastic or wood, more of an engraver than a CNC, but obviously, we'll keep working and see what we can get out of it. So my next job is to figure out how to mount this motor. And then once I have the motor mounted in a position that I'm happy with, hopefully I'll make it kind of an adjustable mount, and probably a 3D printed frame, which will go through the slot into the V-grooves and be held on with some T-nuts so that I can move it around a bit. But once I have that part designed, then I have to redesign the gantry support again, not a full redesign, but basically I need to add a new feature to the inside here, which you can't see from this perspective, but I have to add a new feature in there to couple the belt to figure out that mechanism. And then also a little mount at the end here that'll hold one of these pulleys. It'll just be the idler for the belt, and probably a tensioning system on this end as well. So maybe for the first version I might leave the tensioning system and just do the tensioning here kind of manually as you mount the belts, but I'd like maybe some sort of screw mechanism where I can tension the belts without having to disassemble or anything. All right, so I'm going to get to work on that. progress update. I managed to 3D print the motor mount that I was designing, and I'm really happy with it. It's surprisingly solid. It's not even attached with all of its screws, and it's only half the screws holding this on. There's like tiny little bit of flex in it, but it's pretty good as far as I can see. So I have the pulling method on the end, and I've got kind of roughly set to the clearance that I think I want for it. This might not be the final design. It's, as I'm looking at it, I'm seeing some places where I'd kind of like to maybe improve it. But so far, it seems like it's pretty good. So before I print another one, mirror it and print another one for the other side, the next part now is to figure out how to couple the belt onto this part of the rail where it's going to run. So belt will come down from here and it will be captured here, and then another part of the belt will keep going all the way down to the end where there'll be the idler that it's attached to. So I think the first thing I do, because this is a pretty large piece and I don't want to have to reprint it all over again quite so soon, I probably will figure out the mounting down the far end here, the little idler, just run the belt through that loop just to make sure that I've got kind of my alignments right, and then I'll figure out exactly how to attach it onto here, and that will provide the drive. So I'll prototype it all on one side, and then once it's working on one side, I will, or well, when I have what I think is kind of a decent version, I will mirror all the parts, print it for the other side, assemble it, and test how it moves with the belt attached. All right, that's it for now. Progress has been made. Basically, the last thing I did was I made this little belt coupler thing. So I can now have a looped belt attached together. Turned out pretty well, the design did. It's pretty simple. It's just a little piece in here that has some T-nuts inside it, and then there's little other pieces on top that have ridges, little teeth that can grasp the belt, and then it's all just bolted together and sandwiched down tight. And it's actually without any extra tensioning mechanism. The belt's pretty taut, but not ideal, because to tension it you have to undo the screws and pull the belt and stuff. So it's probably not going to be the final system, but it's fine for now. It will be. So right now it's the tensioning mechanism and the coupling mechanism. In the future it will just be the coupling mechanism. There'll be some other tensioning mechanism, some sort of thing out here that'll either press down on the belt or pull it tight with a screw or something like that. And so this block will essentially attach onto the gantry here, and that will be what allows it to pull along. So that will be this piece will be integrated onto this, and that'll be what allows, as the belt moves, it'll pull the gantry along with it, and there'll be one either side. So that's my next thing to do, is I need to redesign this part yet again to include the belt coupler, which I'm going to use basically the same design. So I have to modify this slightly. I need to make the little lip here a little wider, because that's this had to be made wider to accommodate the screws and the width of the belt. So the only other thing that from this rough assembly, I'm pretty happy with how everything kind of lines up, except for this guy, the little belt guide thing with us. It's just a bearing inside here that the belt can run on. It's way over this way, so it's that way away from, so it pulls it out of line. So when you pull, if you pull the gantry right up to here and you put the block on it, you can see that the belt is twisted like that right up here at the end. So that's not going to be any good. I'm going to have to redesign that part, which is fine. This is all just, again, these are all rough parts just to see, what our alignments are like and that kind of thing. But yeah, pretty happy with that. So yeah, I'm going to go off and redesign this gantry part with the new belt coupler, and then I'm going to redesign this thing. And then hopefully at that stage I'll print duplicates of everything, because so far I've only just been working on this one side, and once I've printed duplicates of everything, I'm going to assemble the other side with its motor as well, and then we can have a go at powering up the motors and seeing if we can make the gantry move.
So these are all the parts that we need to make the belt idler for the y-axis. So we've got the pulley that the belt's going to run on. We've got our little bearing carrier with the bearings fitted in, nicely press fitted, and we've got this little pin that you saw me make, which will go between the two bearings, and the pulley will be fixed onto that, so it'll be free to rotate. The whole thing will be free to rotate on either end, and then you'll be able to move this along the V groove with its with T-nuts, so it'll be fixed through there, and yes, so that'll be let you to adjust the position. Now, one thing that's interesting about this that I wanted to point out was nominally the internal diameter of this bearing and the diameter of this pin are the same, but they don't fit. So this is, it's pretty common, and like they're close. You know, they're, I think if we measure them, they're probably within what are they, about, yeah, so they're within about 0.2 millimeters of each other, which, you know, it's not really great fit wise, but so to get it, like, we need a nice slip fit here, so we need to either, you know, alter the shaft, alter the internal diameter of this, because it also doesn't really kind of fit. Oh, it does actually sort of fit in there. So that's obviously a little looser because I suppose it has grub screws, but the bearings are a very, very, very tight fit, and it won't go through there at all. Now the bearings are cheap, so, you know, I can't really be certain if all that, if the, you know, the what am I trying to say, that the inner diameter of that is all that accurate, but also equally the stainless steel rod is very cheap as well, and it just comes, you know, standard hardware shop stuff, so it's not exactly precision pieces that I'm working with here, so we got to make them fit. Fortunately, so I don't want to alter this bearing at all, because I'd be loath to do that in case I mess up the bearing, because that would just be silly. I've got a lot of this, so I can mess with this as much as I want. It's going to be a lot easier to do. Now if you had a lathe or something, you could, you know, machine it down to a really precise fit. I don't have a lathe. So the next little trick I'm going to show you is just a handy one to know. If you need to take a piece of steel rod like this and just bring it down incrementally for a fit, basically what I'm going to do is I'm going to chuck it into my drill, and then using a little bit of water, some sandpaper, and maybe the Scotch kind of bright wheel on my angle grinder, just to basically polish the surface of it, take down the diameter like a tiny amount. You're really not taking much off at all. So it'll clean up the surface, reduce the friction, and bring the diameter down just the tiniest little amount, so that it will slip fit through the bearings. So what I'm gonna do is I'm just gonna kind of go over that, you know, several times, make sure that it's a nice fit, and yeah, just keep testing it, and then once I get that slip fit that I want, done. We have reached a huge milestone. Basically, we have a gantry with a belt attached to it, attached to the motor, attached to an idler on the front, and the motor can move the gantry. Look at that. So it's obviously just one side, the other side still has to be done, so it's actually, as I twist it, it does catch occasionally on the far side, which is as expected because it's not being driven from both sides yet. So yeah, I'm very excited about this. I managed to get the parts moving pretty freely, nice and smooth. Yeah, so it's pretty good. Next thing is to print the parts for the other side. I have to print the motor support, and I already have the other gantry support with the belt coupler built onto it, so I need to install that on the far side, replace the old one, and then the next thing we can do is wire up the motors and get some power to it and see if it can move on its own without me having to kind of babysit it as it goes. So that's next. So we've reached another milestone. I feel like I say that a lot, but I feel like getting through this project for me has just been trying to hit every little milestone one after the next so that I can then figure out what I have to do next. But yeah, so this piece of progress we've made here, we've got all of our parts assembled for the y-axis, more or less. We've got the belt idlers, we have our gantry supports with the belt couplers on them, and we have our 2 motors mounted on either side. And they move! Look at that! So this has just been assembled, literally just assembled. I don't have the tensions on these right or anything like that, and there's infinite amounts of adjustments that I have to make this run smoother, but I'm pretty happy. It moves. The motors turn, and if you spin the motors, they move the gantry along, which is pretty cool. It's almost like that's exactly what it's meant to do or something. So yeah, that's pretty good. The next thing that I'm going to do, and then I'll probably leave it at that for this video because I think it's going to start getting super long otherwise, is I'm going to wire up the motors. So basically wire them together so that they'll be essentially both driven by the same, pulses and everything, so that they should run in sync. I'm making a lot of assumptions about how in sync they will run and stay, but hey, we're going to try it anyway and see what happens. So the next thing you're going to see is, hopefully, when I've done some wiring and written some code, you're going to see this gantry moving on its own under the power of the motors. Okay, so it's been a while since I've recorded. We've now had a Christmas and a New Year's since the last time I was talking to you on this video. So Happy New Year's. Anyway, basically I've done some work here and gotten some wiring working. So I've wired up the motors with this very temporary setup just to test that they're working and test that I can make things move and that I haven't made a load of terrible mistakes. So this isn't going to be what it's like in the final version, but it's just a little quick test rig. So we've got a 12 volt power supply connected here, which you'll see now when I turn it on, it can only supply about 1.5 amps, which isn't really enough for the motors to move against the load that they have on this. This driver circuit I have is a DRV 8825 stepper motor driver. And so I've adjusted the trim pot as best I can to get the current right for these motors. It doesn't sound great, but it is working. And then this is just a really simple, just an Arduino clone, Borderless Electronics Arduino Leonardo clone to drive the whole thing. And I have the 2 stepper motors connected here. They're connected to the same driver, but the trick here is to make them, because they need to spin in opposite directions because of the orientation I put them in, you just basically connect them backwards but connect them together to the same drive signals. So I'll stick on the power and you guys can see how this works. Ooh. And there you have it. The y-axis moves. The noise is extremely irritating, I know, but none of this is the final versions or anything, and I'm personally just really happy that it moves. Alright, so I'm going to leave it here for this video because it got pretty long. So the next steps on this are, I need to figure out actual wiring, actual power supplies, probably make a kind of a box enclosure for the underneath of it, which will be where all the electronics go, and then I have to start designing the x-axis. But for now, I'm pretty damn happy with this progress, so stay tuned for the next one. Hey everyone, thanks for watching the video. If you liked it, make sure to like, subscribe, and share the video. If you'd like to support the work that I'm doing, you can find a link in the description to my Patreon. And as always, thanks for watching.